Hello students, this is Devarchana Raut, lecturer in computer science. So in our previous slides we have already discussed insertion operation in linear array. We have already discussed about insertion at the end of the array, insertion at the beginning of the array. So in this slide we will be discussing about insertion at any given location or any location of the linear array. So, first of all, we already know that for inserting any element in the array, first we have to check is the array having any space to insert actually, or if it is full, then we cannot operate insert operation. It will just print overflow and it is going to exit. So for that we have a condition. At the first step, we check the condition that is upper bound is equal to max minus 1. If it satisfies the condition, then it means that the linear array is full. If it actually does not satisfy the condition, then it means that we have a space for insertion of an element. So we are taking an array A of size max. At the very first step we will be asking for the condition is upper bound is equal to max minus 1. If it satisfies, then it will print overflow and it will exit. That is the end of the program. But if it does not satisfy, then we will come to step 2. In step 2 we have to read the data that we want to insert at any location of the linear array. So after reading the data, we actually in the third step have to read the location too, that where actually we want to insert the element in the linear array, as it is the algorithm for insertion at any location. So we have to specify the location in which the data we want to insert. So after step 3, at the step 4, similarly as we were doing in the insertion of the element at the beginning of the array, similarly here also it is most over similar to that thing, but the only difference is that we were running the variable k from upper bound to actually the lower bound. The condition was being checked from upper bound to lower bound. But here, if we are inserting any element from any position or any location, then the variable k is going to start from the upper bound and will run up to that location only. Not up to the lower bound, rather it will just run up to the location. So let's see the fifth step. In fifth step, it says that it will repeat the step 6 and 7 until the k variable is greater than equal to the location. So here you can mark in our previous algorithm, that is insertion at the beginning, here it was that the k was running from upper bound to the lower bound, but here we don't have actually go to the lower bound. We have to insert at the location. So the k is going to run up to the location only. So what it has to do in step 6 and 7? In step 6, similarly the a of k value will be just assigned to a of k plus 1. That is from the location position only we are going to shift one element to the adjacent position, or we can say to the next position. Okay. Similarly, again at the 7th step, we are going to decrease the k value by 1. Okay. It will run until we are just getting or we are just reaching the location where we want to actually insert the element. Okay. So once we reach up to that location, we will allocate the data at the specified location as we have read the location, then we will exit. So by taking one example, let's discuss this. For example, we are taking an array A which is of size 5. Okay, so size 5 means that there must be the max value is 5. Okay, so the index value will start from A of 0 up to A of 4. So A of 4 is the max value. Now first we have to check that is the upper bound is equal to max minus 1. So for example, there is one space in the linear array so that we can insert the data. The data are filled up to A of 3 position. A of 0, 1 data is filled, A of 1, 1 data is filled, A of 2, 1 data is filled, and A of 3, 1 data is filled. A of 4 position is, for example, empty. So the upper bound will be, as the data are filled up to A of 3 position, so the upper bound is 3. Okay, now I have to check is 3 is equal to max minus 1. So the max value of the array is 5. So we will check that is 5 minus 1, that is 4, is equal to the upper bound. We already know the upper bound is 3. So it is not satisfying the condition. Then it will come to the second step. At the second step, we have to read the data which we want to insert in the linear array. For example, I will take X is an data I want to insert in the array. Next, at the step 3, we will read the location, as the algorithm is insertion at any given location. So at the step 3, we will read the location we want to insert the data. So there is one variable LOC which is taken to take or input a data where I want to insert or take the location in which I want to insert the data. So for example, I am taking the location 1, location 0 is the first position, A of 0 is the first position. I am choosing location 1, A of 1 to enter the data, or the second position of the linear array to enter the data. Okay. So next what I have to do, I will assign the upper bound equal to k. I will take a variable k which will be assigned the value of upper bound. Now the upper bound is, I have already told, the last element in our linear array is A of 3. Okay, so upper bound is 3. Next, I have to check is 3 is greater than equal to the location. The location was 1. The upper bound or k value is 3. Yes. So it is satisfying the condition that 3 is greater than equal to 1. So what it is going to do, now it is just shifting the value at A of 3 position, or it is assigning the value at A of 3 position to the next position, that is A of 3 plus 1 to the fourth position. Okay, as we were doing in the insertion at the beginning process. Okay, so it is shifting A of 3 to A of 4, it will shift A of 2 to A of 3, it will shift A of 1 to A of 2. Okay, so the condition will just run up to the location, because A of 0 position will stay where it is. I have to shift or insert the element at the A of 1 location. So from 1 position, it is just going to shift one element. For that shifting process, I have to use steps 6 and 7, as we have discussed this previously in our slide while explaining the algorithm for insertion at the beginning of the array. So steps 6 and 7 will be running. Okay, so after it reaches the location, again obviously it will decrease the k value by 1. Okay, so the location is 1. After decreasing from 1 minus 1, 0th position, when it will check the condition, is 0 is greater than equal to the location. Now the location is 1. the k value is 0. Now it is neither greater nor equal to the location. So what it will do? It will not repeat the step 6 and 7 anymore. Rather, it will just enter the data in the location. We have already read the location at the third step. So it will just enter the, we have also read the data at the second step. So it will just read the data, or it will just allocate the data at the given location position. Our insertion operation is done. Now I am going to stop at the 9th step. It will stop and just exit. So I hope in this video you have understood how we are going to insert any element in the linear array at any given location. So this was the algorithm for it. Thank you.